So these are the steps involved. These are the fundamental steps involved to train your model. In between, we have some other steps also there. I'm not going to complicate this at this moment. So these are the steps you remember, right? We need to have the data. Without data, you cannot do anything. Whether it is a machine learning model, deep learning model, or if you want to create a simple report in Excel also, right? You need to have the data in place. Without data, you cannot train your model. So you need to find out the data, right? You need to extract the data, talk to the business stakeholders, and then find out from them, where you can you can extract the data that are required for you to train the model. Once you get access to their source system, you need to extract the data and then you need to perform exploratory data analysis, which means you need to explore the data, both from the business as well as the quality of the data point of view. While exploring the data, you might tend to find some interesting insights. That insights might help you to come up with some strategies to tailor your marketing strategy also. Okay. And the next step is, yes, I have explored the data. As part of my exploration, I have noticed that there are some issue with the data. So in that case, you need to address those issues. Okay, you need to address those kind of issues. That is what you basically want to prepare the data to train my model. Okay, to train my model, make sure that the data is clean and it is good enough to train my model. And then, if required, you can add additional columns or the features in addition to the columns that you have in your data set, and then you train your model. Once you train your model, you need to evaluate your model, how well my model is predicting. The whole objective of machine learning or deep learning, anything, right? You take any AI, the objective is it has to make a prediction. Okay. So in this case, yes, the model, how well it predicts, is that accuracy is good. If somebody says, right, tomorrow it is going to rain, and if they say yes, 90% it is going to rain, and tomorrow if it is not going to rain, what do we say? The weather forecasting was not accurate. Okay, so there is no point in saying that, yeah, we trained a full-blown model. It can make predictions if you throw any data to the model. It's not that how well my model, how accurately my model predicts. That matters a lot. So that we will evaluate using some metrics. And then what we do is we do the fact packaging. Packaging is using Docker. We containerize the application. That means you take all the dependent codes, the data, everything, right? So, sorry, no, yeah, everything, and then you can package it. Okay. And finally, we deploy it to the production system. This is at the high level. Again, in between, so many steps are there that we will discuss at later point in time, because you need to create the automated pipeline. How do I create the automated pipeline? All the things, right? We will see in the next session about the AWS code pipeline, using which you can do the automation, everything. Okay. The next, what we'll do is today we will focus on the packaging part. This is the one I have shown you. I just go back to my, one second, I just go back to my AWS cloud again. I just show you what I did it. So this is my AWS cloud. Look here. Once you log into your AWS cloud, I just show you here again AWS console. And then here you need to sign in. So once you sign in there, in my case, I have the credentials. I just signed in there. And then once you signed in there, you need to click on EC2. I just clicked on the EC2. Currently, I'm in EC2. And when I selected the instances, I could see these are the instances. This is the instance I'm going to work on it. And I just clicked on connect. It got connected here. Okay. And now what I do is I just type ls to list the um, files and folders that are available in this default home directory of my user ID. My user ID is EC2 user. This is the default username. Okay, you can also type pwd. That is the one will give you the present working directory. Okay, currently I'm in this folder. So usually what we do, right, we have all these things, the script and the data set, everything will be available either in GitHub or in the S3 bucket. For demonstration purpose, I'm just showing you here itself in the Linux system itself in my home directory. So what is my home directory? Home EC2 user. In this directory itself, I kept all the files and the other folders. so that we can simplify this process. Any of end-to-end demo, we will look at it later. Okay. So look here, the file, the train.py is an important file here. So where is the train.py? Look here, the train.py file is there. This is the one. When I execute this one, look here, Python. Um, I think I have some keyboard problem. Yeah, if you type Python 3.12, I'm using Python 3.12 version. And then if you type the train.py, and when you press enter, it will get executed. So that means, right, this file um, trains my random forest model, and then it saves that model with this name, model.pickle. Okay, model.pickle is currently available here. One second, guys. I have some problem here. My keyboard, yeah. Keyboard is working. The T letter is not working. See, the T is not okay. Anyhow, no problem. So what I will do is I will just cat. Okay, here T will not work. Okay. Otherwise, I will do one thing. Nano, and here okay, train.py. Okay, I just do it. It's not about keyboard. Some virus problem. I'm using external keyboard also. Even that also not working. Okay. See, nano train.py, this is the one opens my script file in the Linux system. This is AWS Linux. It is almost similar to your Red Hat Linux when it comes to command everything. Okay. And if you see the blogs and other YouTube videos, most of them they use Ubuntu Linux. That is not going to be helpful. But when it comes to Linux, where almost the commands are similar. Okay, let's forget about Linux flavor. So this is my script file. So the sklearn is the machine learning package. We will see SageMaker later point in time. Sklearn, right? Scikit-learn, using which we are going to use all the packages relevant to machine learning. We are going to import it. That's what I did it here at a high level. Okay, let's not get in too much of technical. So again, we need to tell the model, right, which data set you want to train. So this is the data set, you take it and you train it. And then the pre-processing, right? So we are creating two different variable. The variable X is holding in the input features. The variable Y is holding only the dependent variable or the labeled variable. So I discussed in the previous session what is input features, what is a labeled output variable, right? So the four measurements related columns are called your input features, and then species is the labeled column. So I'm just storing all the four input features in a variable called X, and the labeled variable species I stored in a variable called Y. Why I have to use X and Y variable? Because I have train and test split method. Here, the first two arguments. If you specify X, Y, it will be easier, right? Instead of putting big thing here, it will be helpful if you just put a X comma Y later point. And if you want to refer it back, that will be very simple. And then set test size is 0.2. That means take 80 percentage of the data randomly for training purpose. Remaining 20% you can use it for test purpose. Ideally, I should have used the entire data set. Anyhow, let it be there. At this moment, you can ignore that. So you just think, train and test split is happening, and this is my random forest machine learning model. And if do not know what is random forest model, you can attend our machine learning sessions. Okay, that is happening tomorrow. Okay, you can attend that one also. So that side by side, if you learn, that will be. This is my machine learning model, guys. You just think about it. If you don't know machine learning, AI, forget it. That doesn't matter. Only thing is common sense is very much important. That is, if you those people have good common sense, and if you pay close attention, you can pick up. So this is my random forest classifier, and this is a machine learning model. This model can help us to classify for any given flower image to this model. It can tell, hey, this is setosa, this is versicolor or virginica. Okay, it can tell us. So now what we did, we have used the training data set to train this model. Okay, training is over. And the next step is we are storing the trained model by the name of model.pkl. This script file, what it does is it takes the training data set and it gets trained, and then it stores the trained model as a model.pkl. It's as simple as that. Okay. And then your model predict everything is there. Once you train your model, you can apply the trained model on the new data or the unseen data to make a prediction. See, it's something like that. You have taken 150 flowers and then you trained your model. Hey, for these kind of dimensions or the measurements, the combination of four columns or features dimension, that that one is Setosa and so thing is Virginica. That's how you trained your model. Now your model has good amount of knowledge about the right so the thing right the different types of flowers. It can make out now because it learned the pattern from those is the 150 flowers data you trained, right? So with that knowledge, if you apply the model on any new flower, it can easily classify because based on the past, whatever it learned, it apply the pattern and then it makes a prediction. This is setos or that is what the whole idea. So that is what predict is all about. Guys, remember one thing very clearly. If you are new one to data science, you just remember two things: train and predict. Okay. So the fit method, when it comes to Python, we have something called fit method using which we train the model using the training data set. And then the predict. Once you train your model, you have to use it, right? So how do you use it? The trained model, you can use it to make a prediction on your any new data set. So that is what the predict method is coming into picture. So the model is nothing but this is what my model dot predict. And then here I mentioned about my test data set makes my prediction. Okay, fine. Everything is good, right? So now what I do is I just press Control X. It will come out of my nano thing. I just go back here. If all I have to do is just type Python. One second. Yeah, Python 3.12. How do I execute that train.py? So Python space the script file name is train.py so that it can produce a this one. It can produce the pickle file. Pickle file is the model saved in the form of pickle. Okay, what is pickle and unpickle? Anybody has any idea what is pickling and unpickling, guys? Pickling is basically it's a process of serializing a Python object into byte stream. Okay, it might be confusing for the beginner. Don't worry about that. So using pickling, what right? So we can save our trained models, as a file for later use without retraining. Okay, using pickling, we can save the model. So that's why the model extension also model.pkl. That's what I have shown you, right? One second, I just type ls. Ls is working fine. Okay. So you can see the model.pickle. The .pickle is nothing but pickle. There is a package called pickle. So using which we have saved the model as model.pickle. Okay, unpickling is the reverse. So once you saved the model, right? If you want to reload the model, the same trained model, if you want to reuse it later point up, you can use unpickling. So that's the reason why if you see the script file, using pickle.dump, we have saved that file as pickle.dump, okay, using which. And if I want to reuse it, pickle.open, sorry, pickle.load. Pickle.load is nothing but unpickling. Okay, in the interview, this is one of the interviews. For our students, they were posing this question. They asked what is pickling and unpickling. Okay, so this is a simple thing. Okay, now to make it cut to the chase, look here. So we have trained the model. The model, so this script produced the .pickle file, .pkl file. Next thing is packaging. Packaging, we did not see it. So what we did, we have, what we did, we have deployed this model in the EC2 server, EC2 itself using the Flask Flask application, right? That is what we did. So usually what we do in real world time, we don't deploy the model directly to the EC2 system. Instead, what we do is before we deploy the model, we make sure that the model is performing up to the mark. In the sense, the model accuracy is really good. Using some measures or metrics, we check it out. If everything is good, then what we do is we do the packaging. Okay, how do you do the packaging? So that is when there is something called Docker comes into picture. Using Docker, we do the packaging. So what is Docker now? That is a big topic. Okay, that's a big topic. What I will do is now instead of going to the demo part, I will just go here and I will just explain what is Docker. First, we understand this one, and then we will get into the hands-on part. Once we Dockerize the applications, in our case, the application is the model, right? Once we Dockerize our application, what we'll do is we will use the Flask API to deploy the model. And also what we do is we will see how we can deploy the same model using the Fast API. Compared to Flask, Fast API is much faster. It is robust because the Fast API is, works on a synchronous mode. Okay, there is something called asynchronous and synchronous. What is the difference between asynchronous and synchronous? Anybody has any idea? DevOps guys can tell me what is asynchronous and synchronous. What is the difference between? Yeah, only one correct answer. How about others? So both Flask and Fast API are frameworks, but when it comes to performance, Fast API is faster than your Flask because the Fast API as a built-in was built on ASGI. Okay, so asynchronous, right? It uses asynchronous programming, whereas Flask is synchronous. So once you deploy your model, you can, sorry, to deploy your model, you can use either Flask or Fast API. End of the day, performance matters a lot because hundreds and hundreds and thousands of users nowadays, millions and millions of users are accessing your model, right? They just throw the data to your model. The model has to throw back them the predicted values. Okay. So in that case, you need to keep in mind your model performance, it should be faster also. Okay, Karthikeyan Vayaburi. Okay, async non-block streams the data, synchronous blocking. Yes, that's correct, right? Synchronous, yeah. The fast APIs application, right? It's a web framework. The fast API is faster because it has it was built on ASJ, asynchronous thing. Okay, whereas the Flask is synchronous for smaller applications. Any POC or prototyping, if you want to do it, you can use Flask. Okay. Other thing is the Flask is very simple and lightweight. It's good for small projects, okay? Whereas Fast API provides more features out of the box, okay, compared to the Flask, okay? And yeah, you have something else called, when it comes to data validation, the other advantage with Fast API is it has a built-in validation using Pydantic, Pydantic. Whereas in the case of Flask, you need to manually validate your data, okay, the quality of the data, all the things, okay, that is what you do. And apart from this, it provides the asynchronous support, which one the Fast API. So that's where it stands out. What we will do is we'll first of all we'll explore what is Docker. So without packaging the model, you can directly deploy the model using either Flask in the Fast web framework itself. We can deploy the model, or using Fast API also we can do it. Okay, directly you can do it. Yeah, Django also you can use it, but Django I did not use it. Okay, but usually when it comes to machine learning model, right, we use either Fast API only. Most of the case, Fast API in the real world scenario we'll be using. Maybe yeah, some application they might be using Django, Karthikeyan. Okay, maybe that one also may be using it. Okay. Yeah, so the thing is right. Now what we'll do is first we'll understand what is Docker and why Docker is used before we deploy the model directly in the EC2. So why don't we use Docker? What is the advantage of using Docker? Docker is basically to synchronize. Sorry, not synchronize. Docker is for containerization platform. Okay, it's a containerization platform. You package all your scripts and then all, which means right, you take your code and other dependencies and package everything into a single container also, so that you will not run into an issues like some things are working in my environment but it is not working environment, right? So you will not be end up with that kind of issues. For that reason, it is a best practice. You need to containerize your applications or Dockerize your application. So Docker is an open source containerization platform. Docker is an open source containerization platform. And importantly, it's a lightweight. It runs directly on the host operating system. This is very, very important, guys. Okay, so I will explain you what is the difference between Docker and the VMware. How many of you used VMware, right? So the VM machines, virtual machines, okay? So that is lightweight and runs directly on the operating systems. For that reason, also Docker gained a lot of popularity. It uses OS level virtualization. This is very, very important, okay? To deliver softwares in packages called containers. It uses OS level virtualization to deliver software in package called containers. Okay, so you just think about this at Docker container. So let's say you developed your application. In my case, I have produced or generated a model.pickle is there, and then to run my model.pickle, there are packages that needs to be installed, the libraries and packages, the dependencies. So all those things, right? What I do is I will first what I do is I'll install all the dependencies, libraries, including my model and other configuration inside my container and then if everything is up and running inside, right, and then I will expose this model. So I will expose this let's including the Flask application. Okay, my machine learning model is there here inside, and then I install the Flask application also here. I started the Flask here, and then what I do is if I want to expose my Flask application which is running inside the container in via my EC2 instance, right? So if I do it that way, that will be good, right? So in that case, you need to make sure that everything is installed inside your container, and then you test it using Docker run. Once everything is up and running, everything is working fine, then you can you can store this Docker image into a centralized place called repository or something like that. Okay, so that people across the location, they can download that, they can pull that previously stored image as a Docker thing, right? Containerized image, right? So they can pull it to other environment. For example, you have Dockerized everything and then you push it to some a repository, either Amazon's ECR, right? So Elastic Cloud Repository, something like that. Okay, one second, I just write it here. ECR. Once you once you containerize all your thing, right? It's something like put all the relevant your application and other dependencies into a box, and then you are pushing to ECR or Docker Hub. There's something called Docker Hub. Okay. Once you push it here, what will happen is people from other locations, they can, if they want to reuse the same thing, right? They can simply, pull it. They can pull it to their other. For example, this is in available in dev environment and QA and production environment. If they want to reuse it again, all they need to just pull this previously containerized application into the respective environments. Again and again, they don't have to retrain the same thing. They don't have to redo all the stuffs, whatever we do it in the dev environment, in other environments. It saves a lot of time. Okay, now the question is, okay, fine. Now I just, installed all the relevant dependencies, everything inside my container. Fine. Okay. So how it is different from my this one, the VM machine. Okay, that before we jump in there, first we will understand. So why do I need to use Docker? consistency. As I told you a while back, once you Dockerize your application, which means you package not only your application, all the other components that are required in order to run your model smoothly, you packaged everything in a box kind of thing, right? So what happens when other users or other environment, when you push that image, it has to work like how it worked in your local system or in your development environment. Hence, consistency is maintained. Okay. So it ensures that your application runs the same way in every environment from development to production. That is the beauty of Docker. Another one is isolation. What is isolation? The containers are isolated from each other. You can create more than one container also, right? And the OS system. And also what happens is it improves security and reducing conflicts. Okay, reducing conflicts. Okay, in that kind of situation, you will not run into any conflicts. Next one is the portability. It can run on any system. Okay, that supports Docker. Okay, like Windows, Mac OS, and Linux system. Right, almost all the Linux system it works the Docker. Okay, and then next one is the efficiency and scalability. Okay, because what do you mean by efficiency? It shares the operating system kernel itself. It just shares the only the operating system kernel. Hence, it makes it more lightweight. See, what I am trying to say is, right, see what happens in the past, there is something called virtual machine. How many of you have used the VMware? Simple example, for example, this is my laptop. In my laptop, I have installed Windows operating system. I want to test my application in Linux system. So in that case, what should I do? I have to buy another laptop. So rather, there is a software piece called VMware and Oracle's other process. I forgot that name. Something virtual box. Yeah, virtual box, something like that. So all you do is just download that VMware. In that VMware, you can install your Linux. That's all. You don't have to buy another laptop. Whenever you want to work, for example, you just like how you open your Power BI tool, right? Or let's you have another tool is there. If you or let's Microsoft Word. If I want to open a Microsoft, if I click on it, like how it opens, right? Similarly, you just think this is my VMware. When I click on it, it will open it. It will take some time to boot the Linux system, kernel, everything. And once it boots, I can work on it side by side. I can put Alt Tab and then I can work on my Windows also. But thing is, the virtual machine is very expensive. The reason is it consumes a lot of resources. Virtual machines, it consumes a lot of resources. Okay, because see the simple analogy is right. The difference between the virtual machine and Docker. This is your Docker and this is your virtual machine. Virtual machine is something like so both of them are virtualization. What do you mean by virtualization? Like I said, I can work on Windows as well as I can work on Linux system using the VMware application. VMware is something like virtualization, right? So I don't have to install the Linux using dual boot and also another headache. Or other option is I have to buy another laptop to install Linux separately and one laptop for Windows. Okay, that I cannot afford. Okay, so in that case, what we do is we install the VMware software. So with that, what you can do is being inside the Windows, you can install the VMware. By opening the VMware, by launching the VMware, you can work on Linux inside the VMware also. Okay. So the simple analogy is the difference between Docker and the virtual machine is supposing, right? Let's say you are a bachelor looking for a rent. You are looking for a room, right, for rental purpose. You have two options. One option is renting an entire flat itself. Okay, let's say you are renting a two-bedroom flat. So you will get a full kitchen, bathroom, and living space. But you must cover all the cost is very high, right? To double bedroom house in the prime area. Let's say you are living in very close to your company, IT company, Whitefield or something. The rent is very high if you go for an individual flat. And the maintenance fee, right? And the cost is high. So some things, the same thing is applicable with the virtual machine. Okay, so if you see here, right, the image, in this case, each virtual machine needs an underlying operating system needs to be installed. Okay, so it has an underlying the operating system. Here also your Linux, here also Linux. You want to run your three different applications. What happens? You need to install in each VMware the three different the operating system, and then you need to test it. Right, the same as you look for an individual house. In that case, maintenance cost and the for a single purpose person, right, you need to pay more. Okay, so right, that is similar to your virtual machine. Okay, where each instance runs its own complete operating system, guys, and uses lot of resources. Okay, so on the other hand, let's say you are renting just a room in a shared apartment. In that case, in the single flat itself, three people are staying. Okay, all three of you guys, living in four people are there in a flat. Okay, so two bedroom, so two persons staying in each room, and the kitchen and bathroom is common, right? So in that right, so in that case, you save a lot of money and effort. That is like your container. Renting a shared apartment is similar to your Docker, and renting an individual apartment is similar to your virtual machine. You just think that way, okay? So both of them support virtualization. The problem is here the cost is very high. It's very slow. Okay, for that reason, right? The Docker container is very much helpful. It's a lightweight. It runs directly on your operating system. If you see here, the Docker engine is runs directly with your the operating system. In this case, it simply shares the operating system to each and every container. Whereas here, what happens, each VMware virtual machine needs an operating system, full-fledged operating system. These operating systems are managed by a software called a hypervisor. Okay, that is the biggest problem. So virtual machines are something like your EC2. I shown you a while back in the AWS cloud, right? So it's running an entire operating system inside them. So each virtual machine has its own gust OS and HyperOS hypervisor that manages them. Okay, this is the one makes the the virtual machines heavier and it is costlier. Okay, because they need more memory, CPU, and disk space for each thing. Okay, so in the case of Docker containers, right? So it shares the OS host kernel. It shares the host OS kernel to your containers. Okay, they don't have their own OS. Each container does not have own OS, which makes them much faster and lighter than virtual machines. Simply, it shares the underlying operating system's kernel to other, the other thing, the containers. Okay, hence it is lightweight. Okay. Okay, now you understood, why the containers are popular than the virtual machine, and okay, because the containers share the host OS kernel. It does not have its own operating system. The opposite is this one. In the case of virtual machine, it owns the operating system. That's very expensive. Okay, now let us learn two other terms. So I told you Docker is meant for containerization, which means you can package all the application, so the application and its all the other relevant or dependent files into your Docker container. So Docker container, there are two types, right? So one is Docker image and container. Okay. So what is an image? What is a Docker container? What is the difference between these two? You should be knowing it. How many of you data scientists here? What is the difference between image and container, Docker image and Docker container? You just, you think of images and containers like building a house, guys. This is something like your blueprint, your house blueprint. Okay. So Docker image is like a blueprint for a house. So it contains informations or instructions, right? Similarly, in the case of Docker image, it contains all the instructions like operating system and then the code dependencies, right? So the like in the case of house blueprint, you have where you need to have the what room in which direction each direction, what you need to have, which direction. Like you have, the instructions, right, to build the house, where you need to give the tap, all the things. Okay. So you cannot live in a blueprint. It's just a static plan. Okay. The Docker image is immutable. You cannot modify it. It's a static template kind of blue. You just think literally like the house blueprint. Okay. Just a design kind of thing. Okay. But when it comes to Docker image, same thing, but it contains all the instructions needed to build your container. Okay. What is a container? Container is the actual house. See, blueprint is there. Can you live in a blueprint, right? You cannot live it. Yeah, blueprint takes, takes disk storage. Blueprint takes disk storage. Okay, no CPU. Okay, correct, right? So no CPU, nothing, right? Just a blueprint. That's why I said. See, I have a paper, bigger paper. That's a blueprint of my house. Just because I have blueprint, can I live in that? It's just a static plan. Okay, see, the same thing is applicable with Docker image. Here, you just specify all the dependencies, OS, everything. Next one is container. Container is your actual house. This is where you are going to live. So a Docker container is like an actual house built from your blueprint. Okay, so you can live in it and modify it and even create multiple houses from the same blueprint. Okay, so the container is something like your actual house. Mutable, this is immutable. Okay, static, this is immutable. Like how once you stay in your house, you can modify the house, you can customize your house, and you can create multiple houses also, right? First floor, second floor, or you can add additional rooms also. Same way, right? You can do it here. Okay. So here, if you don't need it anymore, right? You can also demolish it. But the blueprint remains. The blueprint remains intact. If you demolish your house, that's all. But blueprint will remain as intact, right? The same thing is applicable here also. So with this analogy, I hope you understood what is the difference between these two. The key difference is the image is a static, read-only template, guys. Container is it's a running functional instance, right? Right. So it's a functional instance. Okay. It's a real thing. Okay. Real usable house. You just think that at this moment. Okay. I'm not going to talk, the more technical stuff here. So these are the blueprints of the application. It is lightweight, standalone, executable package and runs directly on the host operating system. Okay, and runs directly on your host operating system. Okay, someone asked this question. Are there any alternative to Docker, sir? So do I need to use Docker only? No, no, you have some alternatives are there, like Docker. You have something called Podman. So how many of you heard about Podman? Even I did not use Podman, but I heard from other people. Okay. Okay. So in the case of Podman, it doesn't require a background daemon and all. Okay. And there is other things called uh, LXC, that is for system level containerization. LXC, Linux containers. That's all I know as of now. Okay. Fine. But this is a widely used and a popular containerization application. Okay. It's a runtime instance of an image. It's a lightweight. So the image is your housing blueprint and a container is your actual house. So container is an instance of your image. You just think that way. Okay. Next one is the Docker architecture. If you say you have done Dockerization everything, you should be knowing it. Oh, yeah, Rocket. Very good, very good. I forgot it. Yeah, now I remember. Who is this? Who is the gentleman? Yeah, Karthikeyan Vayavari. Very good, Karthikeyan. Okay. Podman, RKT, Rocket. These are the alternatives for, and also CRIO, right? Cryo. Okay. Very good, very good. Yeah. And you mentioned some other points, template. What is that? I'll just maximize it. So image is a template blueprint, takes disk storage, no CPU memory. Okay, correct. So next one is the Docker the architecture. If you say you did some Dockerization, containerization, you should be knowing the architecture. Okay. So here we have the Docker client, Docker host, and registry. Okay. And if you see here, you have something called Docker daemon. What is daemon, guys? How many of you are aware of the term daemon? In Linux, daemon is equivalent to your Windows service. For example, you have installed a software, and after you install your software, as you know, when it comes to Windows, you need to restart it. Once you restart your Windows, and you can see that specific application related service will be running. How many of you have used Power BI? If you are working on Power BI, you know the gateway, right? Power BI gateway, you need to install it. Once you install it, when you go to the services, you can find the gateway services will be running there. If the service is down, you cannot publish your report from your local system to cloud. Okay, the daemon is something like the Windows service. Okay, this has to run behind the scene. Otherwise, you cannot do anything. Okay, so now see here the Docker daemon. This is a background service. So running on your host. This is the one you know, manages building, running, and distributing your Docker containers. Okay, building your Docker thing, and then running the Docker container and distributing Docker containers. It's all possible because of the Docker daemon. Okay, if this daemon is down, you cannot do anything. You cannot run your Docker, all the things. And the next one is the Docker client. So it's a command line utility. Okay, so by using which we can build our Docker image, and then we can and then we can store the Docker image into a registry. Later point time, if you want to reuse it, you can pull it using Docker pull. And once you build your Docker image, if you want to run it, right? So to create a new container, so you can use the Docker run command to create a container, all the things. Okay. So, and apart from this, we have Docker objects, which is nothing but the images, Docker image, Docker containers, and plugins, volumes, and other objects. Those are the components. So, and at a high level, you understood the Docker architecture contains Docker host, client, and registry. So, the Docker host, you have the Docker daemon will be running. This is the one responsible for managing, building, and running, and this kind of a manager. Okay, he's the one manages all things. If you want to build a new Docker image, if you want to create a container, everything, right? So this daemon has to be up and running. He's the one instrumental in terms of managing all these tasks behind the scene. Okay, and then the Docker are the registries, right? So this is where you store your Docker images. Once you build your Docker image, you store it in your Docker image. There is something called Docker Hub. It's a public registry. Anyone can use it. Okay, you can store it in the Docker Hub. Once you containerize your model, you can store it in your Docker Hub, but it is not secure one. What we do, right? So you can use either Amazon's ECR. Okay, so the repository, right? The Elastic Cloud repository. You can create a repository there, and then we store the containerized application in my ECR. Okay, but for the sake of security, all the things. Okay. So now that, guys, you have a basic understanding of Docker. Okay, next one is the installation. How do I install the Docker? The installing Docker, you can do it in Windows and Mac OS also. You can do it AWS, Linux, and Ubuntu. And in the real world scenario, you'll be installing it only in Linux operating system. So if you are working on AWS cloud, so most of them they'll be using AWS Linux. This is one of the Linux flavor. And again, depends on your client. So if they prefer only Red Hat, you can. So now you'll have to install your Docker on the Red Hat Linux. Okay, but the installation almost similar in the case of Red Hat and the AWS Linux. So there you need to use this command yum install docker -y. But if you specify yum install docker, right? So it will not get installed. You need to. It will say you don't have rights to install it using your user ID. It requires some kind of admin privileges to install it. So even though you do not have admin privilege, using sudo command along with this, you can install your Docker. -y will install all the dependencies related to Docker. Okay, sudo yum install docker -y. Windows, you can go ahead and download it from the net, and then you can install. But here you don't have to download it. Okay, simply you give this command, it downloads everything, and it gets installed automatically. Okay, and but here you need to download it and you need to install it manually. Next one is the Ubuntu sudo apt-get. So if you want to install any packages in your Ubuntu, you need to prefix that with sudo apt-get install and then your package name. Okay. Similarly, when it comes to AWS Linux, you need to look at here, right? So I want to install Docker. So I need to prefix with like this sudo yum install Docker. And if you install any other Kubernetes, right? Sudo yum install Kubernetes, something like that. Okay. This is how you need to do it. Okay. So these are the steps involved in Windows. It's a simple thing. You go here, download it, and then run the installer, the download installer, software. You need to install it, reboot it, and then start your Docker desktop. Verify the installation. That's all. Okay. And yeah, so this is now we are talking about the packaging stuff in the ML pipeline. So even the packaging also has to be automated. Okay. For example, you make any changes to your code. So as soon as you make any change, it has to be tested. And if model performance is really good, and then only it has to do the Dockerization before deploying it. Okay. So once the Dockerization done, and then in some cases, what will happen in the workflow, we have something like, get a manual approval. Okay, in the before publishing it to other, manually you need to approve it, and then only some senior people, right? They will the some authorized people once they approve it. That's a manual process, okay. But there are cases, yeah, they don't want approval. Simply you can deploy it in other environment. We will test it in staging and other environment. Everything goes well, and then only that is a different thing. So now automating the packaging also has to be done, okay, as part of CD. Okay, now what are the steps involved to create a Docker image? You need to create a Docker file and then build your Docker image, right? First, you need to have this kind of a configuration file. With that configuration file only, you can build your Docker image, okay? And then you need to run the container, okay? And then you need to run the container. Okay, so okay, now the question is, okay, how do I create a Docker file? Okay, so that is again depends on your project requirement. Okay, you need to check with your team people or your the architects. They are the one will help you to come up with the Docker file content. Okay, so here in this case, right, I have used the Docker file which has these contents in it. Okay, so you have something like from public ECR. See here, what I did instead of using the Docker bundle, right, I'm using our AWS public ECR. Okay, colon Python 3.12 Slim. Okay, this is very, very important, guys. So what is that Python 3. So this is very important. See here, in the comment we put 3.8 Slim, but actually I've used 3.12. It depends on the Python version that you use it. Make sure that you put that version. Otherwise, what will happen? It will create a lot of issues and you end up wasting a lot of time. In our case, we are using 3.12. And what we did, right, just because we got this template from the Docker site, we just used it and Docker or somewhere, okay, sorry, site, okay. We got 3.8 Slim and then what happens, it caused a lot of confusions, okay. So, and then we realized, okay, it require the 3.12 version of my Python, okay. This is my the configuration file. Yeah. Once you have the configuration file, this is called, we name this one as a Docker file. You need to name it as a Docker file. Yeah, I write it, don't worry. This, you have something called Docker file. So create a Docker file. In that Docker file, you need to have this content. Okay. For example, right in your Windows also, you can do that. You can open a Notepad++, and then you type all the commands, right? Whatever the instruction that you wanted. So you do it. So here, what is happening here? Here, why we need to have this file? What are the steps it carries out? So this is the one. Docker file is helps us to create the Docker image. Fine. So what are the things are there? So what is that each and everything here? So what this one tells us? Hmm? Let me see how many of you can tell me here. See in this case, right? So I just walk you through this one. And in this case, we are using Python 3.12 Slim, okay, which means um, I'm using Python 3.12 version in my in AWS cloud. Okay. So, okay. So you need to start picking the correct pack. Otherwise, it will cause problem. It is a lightweight version. Okay. It doesn't have extra unnecessary files. That is the beauty of this one. Okay. And it comes from, this one comes from AWS public elastic container registry. Sorry, not cloud registry, container registry. Okay. So this is a very trusted and verified image. Okay. But because in most of the projects, right, when I worked with AWS cloud, we were told very clearly we have to use this one. Okay. And yeah, so somebody asked, what is Slim? Because it makes the containers smaller and faster. Okay. What happens, it doesn't contain the extra files, only the necessary files only it will have in it, which one, the Python thing. And then the next one is you need to set the working directory. Okay, you setting directory inside your container. So all these things are inside your container. You just think about the box. Inside the box we are, what we need to do, that is what we have instructed here. Okay. It's something like, right, hey, let's work inside the app. Let's work inside the app folder inside my container. Okay, got it? It's all, we do it everything inside the container, not at the operating system level. Okay, so all future commands will run from this directory only, guys, once you specify this. So why do I need this app? Good question. Someone asked this one. Why do I need this, app? Okay, so to keep things organized, guys, and make sure your app files go to the right place. Okay, that's the whole idea of this one. Okay. And then, yeah, copy dot app. What this command does, copy everything from my current project folder from my computer into inside my container app folder. This includes Python. Yeah, just a while ago, I showed you in my AWS cloud, right? In that folder, PWD, I just type PWD. PWD is Linux command, present working directory. Home EC2 user in that home directory. So you had seen train.py, model.pickle file, requirements.txt was there. That requirements.txt is nothing but all the packages that are required in order to load my model and make predictions and deploying my model on the cloud. All the packages, Flask application, Flask name, Pandas, NumPy, all the Python related packages, and including Flask, it was there. Okay. So the requirements.txt file was there and model.pickle was there in the current folder. So what this line does is copy everything from my current folder or project folder on my computer into app inside the container, app folder inside my container. Okay. Yeah. Why do we need to do this? Yeah, because container, this is a container, right? Because containers start as a blank slates. Okay. So we need to put our code inside them. Remember that. Okay. Next one is installing the dependencies. This is like, hey, install the Python libraries listed in requirements.txt inside my container. Okay, what is no cache directory? Okay, that's a good question. So this option saves space by not storing unnecessary installation files, guys. Okay, for that reason, no cache directory. So these are the best practices. Okay, knowing what is not sufficient. You should be knowing the best practice also. Enya will discuss about the best practice also if time permits later sometime today or in the upcoming sessions. Okay, so the no cache directory option saves space by not storing the all irrelevant installation file. Okay. So in right without this step, the container won't have the necessary libraries like Flask, all the things. Which one? The requirements.txt and all. The next one is expose 5000. What is expose 5000, guys? This is like I will use port 5000 for communication. And also remember, there is the Flask app by default, it runs on the port number 5000. So we need to expose it. Okay. So that right, when we expose it, what will happen is when we run the container, our app can be accessed by web browser or API calls. If you don't expose it, other applications or via your web browser, you cannot access this app which is running inside your container. Then what is the point in installing an app inside your Flask app inside your Docker file? I just repeated the Flask app that uses the default port number 5000. We need to expose it. Unless you expose it, our app, the Flask app, cannot be accessed by a web browser or other API calls. So it is mandatory. It is mandatory. Okay. But again, yeah, you can specify whatever the port number that you wanted. But this is the default one. Okay. Again, you need to check with your architects. What port number can I use it? Or other than again, the operating system guys, right? Linux, admin, all the people. You just check with them. Are they using this port number for any other thing, right? Okay. So that's why it's all collaborative effort. Okay. Okay. Next one is the CMD Python app.py. This is the one tells the container, right? This is the one tells the container, hey, when you start, run app.py using Python, guys. Okay. Hell lot of programming languages are there. So when you start the container, right? So you need to execute this file using Python. So that, right, the container automatically launches our app when it starts. So the Docker file, to summarize the Docker file, in this case, it helps us create a lightweight, reproducible app. Okay. It runs, right? So it also makes sure that our application or app runs the same way on any system. Okay. For that reason, this is we are building the Docker image. The before you building the Docker image, make sure that you have the Docker file defined. Without that, you cannot build the Docker image. What is the next step? Next step, okay. The first step one is create a Docker file, and now we have created a Docker file. Explained you each and every line of the Docker file, and then next step is build the Docker image. So how do you build the Docker image? Docker build -t flask app. Okay. So this is the -t stands for tag. Okay, you give some name for your application. Since it's a Flask app, I just mentioned Flask app, but you need to give some meaningful name. For example, here we are predicting the iris flower. So in the case, you can probably give some project name, iris hyphen pred hyphen flask or something, or iris iris app, something like that. Okay. Dot. Dot means, right, the current thing in the current folder, all the, make sure that before you execute this command, your Docker file, requirements.txt, all the other files related building your model should be available in the current folder. Okay. So when you execute this, it will start build your images. Okay. Sorry, yeah, to build your image. I'll just show here and okay, let me do one thing. Smartly will use the up arrow so that I have whatever the command that I used it, you can, because of the keyboard confusion, the T is not working. It's not my keyboard, sorry, it's some virus problem. Yeah, fast AP also I'm running it, okay? I did not see the Docker build command. 1 second. Yeah, so you need to use Docker uh, sudo. Before that, you need to make sure you are including sudo here. Okay, sudo Docker so sudo Docker build -t. Okay, I just use the same thing here. build sorry build. My T will not work. See, that's the problem. Here, sorry guys, I will just tomorrow I will remove the virus from my laptop. -t. Let's I'm going to give Flask app something like that, okay, or I just give iris. Okay, I'm going to execute this one. Okay, sudo what happened? Docker build start a build. Okay, sudo docker build -t. Sorry, build. It's correct only, right? Build -t. Sorry, here I need to put the dot here at the end. I don't know if I have sufficient space in my EC2. Already I tried many things. Now it is building the image. What is that -t? Yeah, -t is nothing but the flag. Okay, so -t is a flag. This is the one assigns a tag. Okay, it gives the name to the image, guys. So currently we are building the Docker image with this. Now, once the image gets built, that this is how that image name is this one. The Docker image name is this one. So basically, we are naming our image as Iris Flask app. So currently, the it is creating an image. Yeah, the dot, right? The end of the dot is important because this represents the current directory, okay, where your Docker file is located. You can see here where Docker file is located here, right? So, right. So make sure that before you execute this command, all the Docker file and model.pickle, requirements.txt, all the files are available. Relevant files are available in current folder. So now no error. My image got built. Okay. I just type Docker images. Okay, I need to use sudo. Look here, it is throwing an error, right? You don't have permission to execute this command. You need to sudo docker. You can see that the repository is Iris Flask app. This is the image that we created. So the default tag is latest by default. Okay, the default one is latest, and image ID, and this is my image ID and created about a minute ago. And the previous one it shows, right? So latest and 23 hours ago, and something else also got created earlier. Okay, this is what we can see it here. Okay, and next one is we need to run your Docker container. Okay, so what happens is we have created the image by the name of Docker image by the name of Iris Flask app. Now we need to create and start a container. So we have created the blueprint, guys. House is blueprint. Okay. Now we need to have an actual house, isn't it? So for that, we need to use Docker. Okay, I need to use this thing. Previous command keyboard problem. Yeah, Docker run should work, right? Only D is the problem. Sudo Docker run. I'm going to say -P here. Minus P is nothing but the port number. Okay, you need to do a port mapping. What I do is I just say 5000 colon 5000 and then iris flask app. It will throw an error because already I have used the same port number for other image, Docker image. Let us see what happens now. Okay, now okay, that one got, I think it was not using that port number, something else. Now what happened? So running on all addresses, right? So this is your port number. So what exactly -P, look here, I'm talking about this one. What this command does here. So this Docker run creates and starts a container from your image and 5000 colon 5000. The first 5000 is the host machine's port. My host machine's port, and the next one is container port. Okay. So the host machines is, for example, you are starting with your laptop, that is your laptop's system's port number. In our case, the EC2 server, right? So in that case, this is my EC2 server's port number. This is my container port number. Here, what we are doing is, right, uh, we are mapping the machine port number with the container port number. Okay, so this is the one allows us to access our app from our web browser. Okay, so you need to do this one, otherwise it will not work. You can also run, right, Docker, sudo Docker run. You can directly give this one. It will not, in that case, you will not be able to access the Flask application which is running inside your container, right? If you want to access your Flask application which is running or listening inside your container with the port number 5000, you need to map it. Operating system 5000. In my case, the EC2 for local systems port number, I am mapping with my container port number. Now what I do is I just go to my browser. Let me do one thing. I just copy my IP address here. Because in the EC2, you remember one thing. Every time when you stop and restart your server, it will assign you IP address. Look here, it's working fine. Okay. So now if I enter thing, right, like 6, 4, some values, okay, 3, 1 or something, predict versicolor. So with these four combinations of dimensions, right, so that flower must be a versicolor flower. Now it is fine, working fine. Now I go back and I'll check this one now. I just do Control C. Control C is to close that one. And, abruptly you are terminating it. And if I go and refresh it, let's see what happens. It is not, right? I just terminated the service by using Control C. In Linux, Control C, if you use it, something like, terminating that thing. Now what we will do is, I just go here and then I'm going to remove this 5000, 5000, all the things, okay? Docker run iris flask app. If I do this, it will run. Still it is running it. But if I go back here, when I click on it, let's see if this one is bringing up that one. It is not working. Because you did not do the port mapping, guys. You did not do the port mapping, hence it is not working. So I just close this. I terminate this one and I'm going to do the mapping. So what I say here is hey, do the port mapping with the -p option. So you map my containers port number 5000 with my operating system port number 5000, so that you can. So basically, what we are doing is we are exposing our containers Flask application to the external world. Now see, it's working. Now we understood without -p 5000 colon 5000, and with -p 5000 5000, it makes a difference. You need to understand this very clearly. Okay, next one is, yes, this is fine. What is so big deal? What are the other things should I know? So, okay, next thing is I just go back to my PowerPoint. Let's see, I know, did we miss out anything else? So all the steps we carried out, right? So life cycle of a container. This is a basic thing you should be aware of all these commands. Docker build is used to build the image, and then to run the, you need to run the, right? So to run the Docker image, you need to run command, and you can also stop the Docker. Okay, if you don't want the Docker service to run, you can stop it. And if you want to restart the Docker service, you can use the command start. Okay, and if you don't want it, you can remove it. So all these things are called your life cycle. You can create the image, and you can create a container using run command. And if you want to pause it, you can stop it. And if you want to restart it, you can restart it. If you want to remove it, you can remove it. All these things you can do it. In RDBMS world, we say CRUD, right? So create a table and read the table, update the table, delete the table. Same thing, right? So you can do it with this one. So you have commands are available to do all these things. Okay. Yeah. One second here. Some noise is coming. Neighbor. Okay. Yeah. So these are the thing, right? Yeah. So another commands are like I just go here and then Docker info. If you give, it gives me the information about your Docker file. Docker info, right? Version 3.35.08. So all this information it gives you. What I'll do is I always you prefix with sudo. Okay, it gives you all the information. Okay, and Docker info and Docker version. If you want to see it, sudo Docker version. You say your MLOps guys, all these commands you should be knowing it. And Docker images, as I showed you earlier, it gives you all the images, list of available images. We can see it here. Sorry, sudo Docker images. Sudo doc. So what are the images are, how many number of images we created. Okay, and if I want to pull an image from the ECR Elastic Container Registry repository, you need to use some command. Okay, so that one you will see it in the next session. Okay, the life cycle as I told, right? So you can start a container sudo system ctl, and this is a command that we use it in AWS Linux and even in Red Hat also, I think so, the same thing. Okay, sudo system ctl docker start iris flask app, sorry. Okay, here I think start dot. Okay, start, sorry, spelling mistake. Okay, now T is working. So pressing unknown command verb docker sudo systemctl sudo systemctl. Okay, yeah, there is a mistake here. The opposite. Okay, here it is little bit different compared to your Ubuntu Linux. Okay, start docker. You need to give start docker. Thank God T is working. Sudo system ctl start docker. Yeah, you can specify. I just type it. Yeah, system ctl start docker. And if you want to stop it, you can. Yeah, once you start, right? So let me show you this one. Sorry, I should have started with stop. And here stop docker, and warning stopping docker service, but it can still be activated with docker socket. Okay, and here, and if you see status systemctl status docker, you see the status also, and here you can see enabled, disabled, and inactive. This is the one you need to look at it. Okay, it's a docker service. That means the service is inactive. So now we can see and press q to come out of this. And then next one is yeah, the sudo system start Docker. Okay, this is for the entire Docker thing. Okay, software. Okay, start Docker, not the specific instance, specific image or container. Okay, now if you see the status Docker and active running. Okay, now it is running. Okay, now what I'll do is I'll just go back here. Enable. We have something called enable Docker. I just try the status now. Now also it shows enabled, right? So now it is enabled. Previously also enabled. The enabled is an optional thing. Once you start your Docker service, right? It's a service, Docker service. That is a daemon. Okay, if you stop, the daemon will stop. The daemon is nothing but your service. Hmm. PS minus A. If I give that one, it gives me all the things. Okay, it gives me all containers. What are the containers? Including stopped ones. Okay, running one and stopped one also. It will show us which one. Docker PS. With this, you can check whether the whether it is running or not. You look here, created and exited. All the things you can see it. And again with timing, right? You can see it. Okay, there is a question. What is UVI code? What is what is UVA con, and is there anyone aware of the UVA con? Anyhow, that we will discuss it. I will give you a demo with Fast API. Okay, the UVA con is for Fast API. That is an alternative to your Flask application, because Fast API is pretty faster compared to your Flask, because Fast API is asynchronous, whereas Flask is synchronous. You just think of the synchronous is something like sequentially it does the job. Okay, if you do job one after the other, it will take longer time, right? If you do something parallel, it will be faster, right? The asynchronous something like a parallel. Okay. Yeah, so yeah, to answer to your question, UA con is a ASGI server, guys. ASGI, okay? Asynchronous, a GI, I don't remember it. Yeah, the asynchronous, okay? It's a asynchronous services, okay? So always think in asynchronous something like it's not a sequential one, okay? It's kind of a parallel one, okay? Multiple, it's kind of a multi-threading, okay? So, okay, what I will do is I will just show you the fast AP. How do we use the fast AP? What I did, I created another folder. There I kept another Docker file. Cat Docker file dot fast AP. Look here, the Docker file name itself, I mentioned with the different naming convention. Docker file dot fast API. And if I press enter, everything is same. But only thing is here I use a different port number, because you cannot use the same port number. There, let's say if you want to run both container together, which one? The Flask API and Fast API also you want to run it simultaneously. What will happen is if you use the same port number, there is a conflict, it will not run. It will throw an error saying that port number 5000 was used by other process. Okay. For that reason, 8000 I used it here. Okay, 8000 I used it. Same step, you need to rest of the thing, right? I just made some changes to my app.py. So train.py is helpful to produce a trained model file, model.pickle, that is same. The app.py, this is the one I made some changes here. What I'm doing, instead of importing the Flask, I imported the Fast API. That's all, guys. Here, what is my model file? I mentioned it. And I just initialized my Fast API EAPP. This is the one I imported it. And if you scroll down here, right? So this is the one serving my index.html file to get a good user interface, and then the predict. So this is where what happens, predict. Okay, what happens is whatever the data that you enter it in the web browser, that one will be accepted, and then that will be sent to your loaded model to make a prediction. The output will be sent back to your browser when you click on the which one, when you click on the predict button. Okay, instead of using Flask API, I have used this one. And I have already used the Docker build. I created an image for the fast API also. What I will do is I will just execute this command Python 3.12, and here app.py. Let us see what happens. Now it ran, right? So now we need to go and check the 8000 port. Okay, what I will do is before I go there, okay, let me do one thing. I just go and check whether is this still running. This is my Flask app. Okay, it has gone down. Because I stopped it, right? Stopped it, and again I need to run it there. Okay. So 1 second. What I will do is, okay, first we will go one by one. This is, I should not have stopped it. Okay, anyhow, I'm going to use this one. If I go here, okay, it's not running here. 1 second. The fast AP, though it is running there, we need to explicitly call them. Windows UI. Sorry, I should have gone here. And right, so what I'm going to do is there is a we need to start the UI icon explicitly. By doing so, it will start that one. Like a Flask, API, right? A Flask application, if you want to start it, you will start it manually. But here I did not do it as part of my API itself. So what I'll do is UV icon app my application value is app, and what I'll do is I just use host 0.0.0. And hyphen port, here I just say 8000, right? Let us see if this works. Yeah, now it's working fine. The UV icon, as I told you, the Fast API is using the UV icon, which is a agent. Now look here, this is the one. I'll just show you that one also, the Flask API, right? Using Flask API, how we, is that still working fine? I just connect it here. I'll use another Linux command line or instance. And here I'm going to say CD. No, it's correct only, right? Here, yeah, we are incorrect. In Python 3.12 app dot, this app.py, this is where I'm using Flask related files. Now this is also running. What I'll do is I just go back here. This is 5000. I just refresh it. Now, guys, so two containers are running in my single EC2 server. One container is hosting my Flask API, hosting my Flask API. Other container is hosting my Fast API. Okay. So you can run multiple containers. Now the question is, here I have created a separate folder for Fast API. I create another Docker file and then I put everything. Okay. Is there any way, can I use a single Docker file to run more than one container? Anybody has any idea? I repeat the question. Using a single Docker file, can I, run two containers? Yes, that is possible. You have something called supervisor.conf that we will see it in the next webinar. Please stay in touch and we will notify you. Most likely this upcoming Monday we'll be having that session, okay? Because if you have to if you want to become MLOps engineer, it's not that knowing what is sufficient. You need to be technically strong and you need to be, you should know the real time scenarios. Okay, the real world scenario, multiple containers will be running. Okay, so what port number I need to use it, can I use the same port number in case of any issues comes in, how to troubleshoot. And we have listed down couple of issues with resolution that also will share it to you. Okay, so what we'll do is we'll upload all the videos. You can start practice it, don't waste time, and we'll share the link, everything. Okay, my contact number is 98407 not mine, my organizer's number. 98, I'll just type it in the chat window. You can also stay in touch with them so that you can follow up with them about the recorded videos and other things. Okay. Okay, I hope all of you have seen my, our organizer's number. You can look at it. I'm just going to kill this one. So the next assignment is how we are going to, use a single Docker file to set up, to build more than one container image. Okay, and then how we are going to start the multiple containers. That is the one we are going to look at it. We have something supervisor.conf, and with that, how we can do it, we will see it in the upcoming session. It's all real-time scenarios. It's really helpful. And also we'll share the questions, the interview questions, everything in the upcoming webinar. And meanwhile, also I will share it. You just go through on it and practice it. As I told you, don't forget it. Compared to even DevOps engineers, the MLOps engineers,